COVID-19 is a respiratory virus that travels through the air and has caused a pandemic, which means it impacts people over large geographical areas. How can we keep our schools safe during a pandemic?
Social distancing, mask wearing, hand hygiene, and properly working heating, ventilation, and air conditioning systems, or HVAC for short, are important to stopping the transmission of COVID-19.
Spruce Mountain High School was built in the 1960s, and because the HVAC system is older, teachers were given 2 fans to blow air out of their classroom windows to improve ventilation.
Will these fans bring air from hallways into our classrooms? Will we be able to use the fans as the weather gets colder? Can we develop a better system for doing this?
Our first prototype used the box the fan came in to create an air chamber to mount the fan on, and it pushed air against the filter.
By using a smoke pencil, we saw that some of the air went through the filter, but some of it bounced off and went back through the fan in the wrong direction. The air showed turbulence as it swirled and formed eddies. In this corner here, air is being pulled through, but bounces off of the filter and comes back through the fan. That will be demonstrated by this smoke here.
So we changed our prototype to pull air through the filter. This created a stream film lines or laminar flow and made our system more efficient. I figured this out one time I was working with my dad, and he was sanding one of the walls, and they needed a filter through the air, filter for the air so they could breathe better. So they took a box fan just like this and some filter and had the air pull through. And then I had to put in a new filter at my house for heating, and I realized that the filter was used to pull the air from outside into the heating system in the house.
Nice streamlined flow into the filter.
We tested filters with different MERV ratings. MERV stands for Minimum Efficiency Rating Value. The higher the MERV rating, the better the filter. A MERV 8 filter is found in many heating and ventilation systems. The respiratory droplets that COVID travel in are often about 1 micrometer or 1/1,000,000th of meter in size. A MERV 8 filter does not capture large numbers of particles that are this small.
A MERV 13 filter removes 95% of particles that are greater than 0.3 micrometers in size. This allows the filter to remove respiratory droplets carrying COVID-19 viruses.
We tested the MERV 8 and MERV 13 prototypes with a van on them.
A MERV 8 filter had air moving through it at about 100 feet per minute, while a MERV 13 filter had air only moving at 50 feet per minute.
By multiplying the airspeed by the filter's cross-sectional area in square feet, we determined that the MERV 8 filtered air at 225 cubic feet per minute. The MERV 13 only did 112 cubic feet per minute because the air moves through it more slowly as it is filtered.
The MERV 13 filters air more slowly because it has a greater resistance due to its greater filtration rate. You can't simply replace a MERV 8 filter with a MERV 13 in a heating system, as the added resistance might cause the blower fan to fail.
We divided the size of our physics lab by the flow rate of our MERV 13 filter and calculated that this prototype could clean our large lab in 78 minutes, which is the length of one of our class periods. If a classroom size volume of air is cleaned every class period, the system should be effective.
We discovered that taping a MERV 13 filter directly to the fan also works, and we now have a filter system in almost every classroom in our high school.
We also built a Corsi box named for Dr. Richard Corsi, who developed the prototype.
In this system, we use 5 filters and fans to make a cube. This creates 5 times the surface area for air to flow through, which can lower the resistance of the filter a great deal. This causes higher airflow and a shorter time to clean a room-sized volume of air.
The Corsi box can clean the room up to 5 times faster and allows the filter change interval to be longer. Of course, it does require buying 5 filters instead of 1 for each unit.
We examined this $300 filtration unit in the room that we send people to when they have COVID-like symptoms. And this filtration system is a lot like the one we built, except the one we built is around $30 to build.
Other systems do have additional systems to help destroy COVID. Some use ultraviolet C lights, or UVC. Others use ionization to attack COVID. This is a UVC light. Our system just does physical filtration.
We also did an experiment to test filtration. We put different masks over a wind tunnel to test the resistance of these masks. And to test the resistance of these masks, we use a manometer. It's this V-shaped tube with water in it. And when you put a mask on, you should see that the tube rises and lowers. Now, the reason why it's doing that is because the atmospheric pressure is greater than the pressure in the wind tunnel, because the mask is working as a resistor, which means not a lot of air is coming out. And we did this test with the gator mask, which is this wicked thin piece of material. And the problem with this is it's too thin. It doesn't have a high resistance, so it stays almost the same with that. But these two, the disposable and the cloth mask, were the same. They're pretty good. They're pretty good. And this is the system to rate your mask and how good of the resistance they have. So this is the gator mask. And as you see, the resistance of the gator mask is only at 1 inch on both sides. And if we switch to the disposable and the cloth, they're the same ones. They have at around 1.5 on both sides. Pretty good. And that goes for both the cloth and the disposable. Now we use an N95, and put that on there. That one goes just above 1.5 inches on both sides.
When you combine air filtration with mask wearing and social distancing and hygiene, you create layers of protection against COVID.
No single strategy is 100% effective, but when you use multiple strategies, they create a Swiss cheese model of defense. Imagine each strategy is like a piece of Swiss cheese. Each piece has holes. But when you put the pieces together, they make a solid line of defense.
Careful with COVID. Back to the Phoenix Jets. Together we've got this.